All right, welcome back. So today we're going to start Unit 5, our trigonometry. We'll first of 3 trigonometry units. Unit 5 is going to be all about trigonometry with triangles. So we're going to go through right triangle trig today. We're also talking about law of sines, law of cosines, ways we can use it to find area, as well as working with word problems with these trig problems. So right triangle trig, this should be a nice little review from when you covered this in your geometry classes. So right triangle trig is all about relating the 3 sides of a right triangle to one of the acute angles inside the right triangle. So there's a total of 6 different trig functions: sine, cosine, tangent, and then cosecant, secant, and cotangent. Really, for right now, we can just ignore the cosecant, secant, and cotangent ones. Simply because those are the reciprocal identities. They're not going to show up on our calculator, so we're not going to really be able to use them too much for each of these questions, but they will come into play in Units 6 and 7. So sine, cosine, and tangent relates the sides of the right triangle, the opposite, adjacent, hypotenuse sides, to the acute angle involved. And again, opposite and adjacent will switch around based on which acute angle we're referring to, but the hypotenuse is obviously always across from the right angle. Sine is the ratio of opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we can see in this particular example, based on where theta the angle is, 4 is opposite it, 5 is the hypotenuse, and 3 is the adjacent side. It's next to it. So that's why sine is 4/5, cosine is 3/5, and tangent is 4/3. A handy way to remember this is your SOHCAHTOA. Easy way to help remember: sine is opposite of hypotenuse, cosine is adjacent of hypotenuse, and tangent is opposite of adjacent. Now we're going to use this information as well as your Pythagorean theorem and your triangle sum theorem, which adds up all angles to be 180, to find all the missing sides and missing angles of any right triangle we're given. So there's going to be 2 scenarios, really. Scenario number 1, you're given 2 sides. So we're clearly missing side A, opposite angle A. We're missing the values of angle B and angle A. So we can solve for side A using your Pythagorean theorem. We can say that A squared plus your 3.5 squared equals 8 squared. So when we square the 3.5, we would get 12.25. Squaring 8 is 64. Subtracting over the 12.25 and the 64 gives us a 51.75, and then we square root that. And I'm always going to be looking for answers around to the thousandths place for everything we do, with the exception of, again, money, which needs to go to the hundredths place, or something that's involving, like, a whole person has to obviously round to the nearest whole number, or if the directions say otherwise. So this would be 7.194 when we do that square roots. Now, in order to solve for angles A and B, we have to set up trig ratios. Now, I'm not going to use the A value we just found in either of the trig ratios for 2 reasons. Reason number 1, 7.194 is a round off answer. It's pretty accurate because it's a thousandths place, and that generally shows a very good accuracy there. So you would still get something that's very, very close, at least in terms of rounding, probably would still be the same answer anyway. But I generally don't like using round-off answers to calculate other stuff. You start creating rounding errors in the middle of the question, and your final answer could be, again, very close, but technically off. So I won't do that. And then second, in the off chance I miscalculated and got A wrong, if I now use A to solve for another part of the question, I'm now going to have 2 wrong answers, even though I might have done everything correctly afterwards. So I'm always going to use not a calculated value, but a given value. So if I want to solve for angle A, I need to recognize that 3.5 is adjacent to it, the 8 is the hypotenuse of the right triangle, and adjacent hypotenuse means I want cosine. So I would say cosine of A is 3.5 over 8. And the way we solve for that is we take the cosine inverse of our ratio. Anytime we're trying to solve for a trig angle, we're using our inverse trig function. So you'll find in your calculators, there's a cosine button on your calculator. Right above that will be in a different color, say cosine with a -1. That's what you can use to solve this out. And again, refer to one of my videos regarding how to use the calculator with trig problems, typing the different trig portions there. So we get 64.056 degrees for our angle. Now, getting angle B, we could just simply do 180 minus the 90 we're given, minus 64.056 we just found. But again, on the off chance we made a mistake and we solved for angle A incorrectly, I'm now using a wrong answer to find a second answer. They're now both wrong. So for the right triangle trig problems, I'm always going to solve them independent of each other, so that one variable does not affect the other. And wherever possible, really for all our questions we ever deal with this year, I'm going to always try and do that. There's obviously certain times we don't have a choice. Like if we think back to the exponential word problems, we had to solve for k to be able to use it to solve something else. I had no choice. I had to use the k value. But wherever I have a choice, I'm going to try and use them independent so that one answer does not make a second wrong answer. So to get angle B using only 3.5 and 8, well, 3.5 is now opposite angle B. So I would say sine of B equals 3.5 over 8, where again the angle is going to be the sine inverse. So the same idea we just did for the cosine, just doing second sine to get your sine -1 there. We're going to get 25.994 degrees. All right, so that's our scenario where you're given two sides. I'm going to use the Pythagorean theorem to solve for the third side, and I'm going to set up two trig ratios to solve for the two missing angles. The other scenario is where we're given one of the acute angles and only one side, and we have to solve for the other two. So I need to know what side A and side C are in addition to angle B. Well, angle B, if I know two angles, I can just subtract them from 180 to get angle B. So B would be 180 minus 90 minus 26, gets me angle B to be 64 degrees. Now, when solving for side A and side C, I'm only going to use the 26 degrees and the 17 to set up my trig ratios. I'm not going to use the 64 degrees. For the same logic I've always used, yes, the odds of you miscalculating a subtraction problem are probably pretty slim, especially if the calculator is doing the work for you, but I've seen weirder. So I'm going to go ahead and solve for side A using angle A and the 17. So based off the 26 degrees, side A is opposite, 17 is adjacent, so I would say tangent 26 equals A over 17. And the way that we're going to solve for a side length for a trig ratio is we're going to put the trig function over 1 and cross multiply. I get 17 tangent 26 equals A. I don't need to do anything else to it. I just type out 17 tangent 26 in my calculator, and I get 8.291 for A. Now for C, I'm still using a trig function there because while I could use the Pythagorean theorem with 17, 8.291 to solve for C, if I miscalculated A, now C is going to be wrong. So I'm going to do another one that's in isolation of each other. So C is the hypotenuse. 17 is still going to be the adjacent side, so now I need cosine. So it'd be cosine of 26 degrees equals 17 over C. So when I cross multiply, I get C times cosine of 26. So I need to divide over the cosine 26 in order to get C all by itself. And then 17 divided by cosine 26 is 18.914. All right, so those are our two right triangle trig scenarios. Either I'm going to give you two sides, solve for everything else, or I'm going to give you one angle, one side, and again, solve for everything else. And this is your general process. All right. Always make sure you round to the thousandths place and make sure you're using exact values throughout. So if you did want to use the 8.291 to solve for C there for this problem, you need to make sure you store it like we've talked about from Unit 4 there with our K values. All right, so that's your right triangle trig, but this only applies to right triangles. So the next two videos, law of sines and law of cosines, will apply to a more generic triangle that doesn't need to be a right triangle. And I'll see you next time for those two.